In this homework problem, we're going to work on Chapter 19, Homework Problem 8, which talks about earnings per share for a complex capital structure. So we're going to calculate both basic and fully diluted earnings per share. So the formula that we're going to need for our basic earnings per share in the numerator, we're going to take our net income. We're going to subtract any preferred dividends. That is known as the earnings available to common stockholders. And we're going to divide that by the weighted average number of common shares outstanding. So if we look at this capital structure, we're going to see that there's only common stock. There's no preferred stock that was mentioned in this problem. So we can assume that the preferred dividends are 0. So we're going to use our net income of $610 million in our numerator. So all we have to do is calculate the denominator. Now to calculate the denominator, we're going to use the weighted average. So we're going to start off with the shares outstanding on January 1st. That is going to be 550 million. Now those shares are going to get a weight of 12 over 12. So in fact, I should note this. So shares, weight, and then weighted average. The next one we have is treasury shares purchased for cash on September 1st. So we have 9-1. And that is going to be a negative 36 because treasury shares reduce the number of shares outstanding. Well, from September 1st to December 31st, September, October, November, December, we're going to use a weight of 4/12. And in fact, I should put a column in here. So what I'm going to do is I'm going to take 550. I'm going to multiply that by 12 over 12. Then I'm going to take a negative 36, multiply that by 4 over 12. I get a negative 12. When I add the two together, I'm going to get the weighted average number of shares outstanding. So for the basic, in my numerator, I'm going to put my 610 million because there's no preferred dividends, there's no preferred stock. In the denominator, I'm going to put my 538 million. So if I take 610 million, divide by 538 million, I get 1.133, and it says round the earnings per share to 2 decimal places, so 1.13. Now let's go into our diluted. So we're going to now calculate our diluted. And as I said, the diluted uses basically an if-converted basis. So as I said, we enter the land of pretend, and we pretend that all convertible securities were converted as of January 1st. So what's going to happen is, in this case, we're going to have numerator effects and denominator effects. So let's take a look first at the numerator effects. If this was convertible preferred, what would happen is, if we convert the preferred, we wouldn't have preferred dividends. So for the fully diluted, we would just assume that the preferred dividends were 0 if they were convertible preferred, and we use the if converted basis. But in this case, we have bonds. So what we're going to have to do for the numerator effect, we're going to first have to calculate the after-tax interest on the bonds. And then what we're going to do is we're going to add it back to the net income, because if bonds are converted into into common stock, not preferred. If bonds are converted into common stock, if they're not bonds, then we don't pay bond interest on them. So on the if converted basis, we pretend that these bonds payable were converted as of January 1st. So for the year, we did not have to pay back the bond interest. So we're going to add back the bond interest to net income to calculate the new numerator. So let's calculate that. So our bonds payable are 8%, and we were told that they were issued at par. So we were told that the bonds payable was issued at par in 2019, and the tax rate for 2021 was 25%. So since the bonds were issued as at par, the annual bond interest is going to be 8% multiplied by the par value. The 8% comes from the description of the bonds. So notice that they're given that they're 8%. So our annual bond interest is going to be 8% multiplied by the par value of the bonds. Why am I strike through here? I'm not going to worry about it. So in this case, that should be an 8%, excuse me. That's not a percent, there's a percent. So in this case, I'm going to take 8%. I'm going to multiply it by the 400 million. So 8% of 400 million would give me pre-tax bond interest of 32 million. Now I have to calculate the taxes on the bond interest. That would be the 32 million multiplied by our given tax rate of 25%. So that would be 8 million. Now what happens is we pay 32 million in bond interest, but we save 8 million on that in taxes, so net we really only pay 24 million in bond interest. So our after-tax bond interest, we pay 32 million, but we get an $8 million tax break. So as I said, the net is really only 24 million. Now what we need to do is we need to add that back to the net income of 610 million, because as I said, if the bond is common stock, we don't pay the bond interest, so we'll save the 24 million after-tax bond interest. So our new numerator is the net income, add back the after-tax bond interest. So in this case, I'm going to take the 610 million. I'm going to add back the 24 million. So of course, that is going to be 634 million in the new numerator. Now I have to calculate my denominator effect. So now I'm going to have more common shares outstanding as of January 1st. So now let's calculate the denominator effect. So in the denominator effect, we're told that the bonds payable were converted into 49 million, or convertible, into 49 million shares of common stock. So if we converted them as of the beginning of the year, we would have 49 million more shares as of the beginning of the year. So the new shares outstanding on January 1st we take the 550 million that were already outstanding. We would pretend that we converted those bonds payable into 49 million shares. So as of the beginning of the year, instead of 550 million, we would have 559 million. 599 million. Not 559, 599 million. Now we're just going to do the same weighted average that I did up here, but instead of starting with 550 million, we're going to start with 599, and in fact, I could really do the same thing right up here. So what I'm going to do is the same thing that I did up here. I'm going to have my January 1st, and then the treasury shares were purchased on September 1st. So I'm going to have my shares. I'm going to start off with 599, and then on September 1st, I'm going to purchase 36 million of treasury stock, so a negative 36. So I'm going to give each one a weight. So the ones that are outstanding January 1st get a weight of 12 over 12, and the ones that are outstanding from September 1st to December 31st, September, October, November, December, get a weight of 4/12. So those are just labels. So I'm going to put in the actual weight. So 12 divided by 12, of course, is a weight of 1 because they're outstanding all year. 4/12 get a rate of 1/3 because they're outstanding 1/3 of the year. So I'm going to multiply the two and then add to calculate that average. So now I'm going to take my shares outstanding, 599 million. I'm going to multiply them by the weight of 1 because they were outstanding all year. The negative 36 million are only outstanding 1/3 of the year, negative 12. And the two together, my new denominator, 587 million shares. Now to calculate my new earnings per share, I'm going to take 634 million and divide by 587 million, and I'm going to get $1.08. And I like seeing those green check marks.